Hi, so we're going to continue with the calculus course. Today I'm going to solve some exercises using the division rule, the differentiation. So 5x minus 2 divided by x squared plus 1. Let's try to differentiate that. Okay, so we're going to differentiate this. We're going to derive this whole thing with respect to x. So remember the rule? So it's going to be g of x is x squared plus 1 and f of x is 5x minus 2. So it's going to be x squared plus 1 times the derivative of this one, which is just going to be 5. Okay? Minus. And now we're just going to copy this, f of x. So 5x minus 2 times the derivative of this one, which is 2x. Divided by the square of g of x, right? Which is going to be x to the fourth. Well, I'm just gonna put x squared plus 1 squared. Let's see what we come up with here. So let's worry about the x squared in here. So I got 5x squared in here plus 10x squared minus 10x squared. So 5x squared minus 10x squared equals minus 5x squared. Okay, now let's worry about the x. The only way that you can get an x in here is, which is going to be plus 4x, and then plus 5, because it's just the way it is. Divided by, if you want to expand this thing here, it's going to be x to the fourth plus 2x squared plus 1. And that's it. That's the derivative. It'll be g of x times the derivative of f of x minus f of x times the derivative of g of x divided by g squared of x. And there you go. I think it's right. 5x squared. In here we got a minus 10x squared, so it's minus 5x squared. Got a minus 2x in here, plus this times this minus, it's a plus 4x. Okay, and the only independent term that we have in here is the 5 times 1 plus 5 divided by this. That's it. Okay, now let's see another example. We're going to differentiate 3 minus 1 over x divided by x plus 5. I'm going to differentiate this whole thing with respect to x. Let's go. It's going to be x plus 5 times the derivative of this. Well, it's just going to be, in this case here, it's 0, right? Minus, I'm just going to put this minus here, and the derivative of this. Well, 1 to the x equals x to the minus 1. So differentiating this, we're going to get minus x to the minus 2, which is minus 1 over x squared, right? But this minus is being multiplied to this minus. So it's actually a plus 1 over x squared. Okay, I'm going to erase this stuff in here. So we have, oh, actually it's, yeah. Gotta multiply this, right? Gotta multiply this. Because it's g of x times the derivative of f of x. And the derivative of f of x is this. Okay, minus f of x, which is 3 minus 1 over x times the derivative of g of x, which is just 1. And this whole thing divided by x plus 5 squared. Now you know, if anybody wants to develop this stuff, you can do it, expand it, you know, multiply it out. If you want to do that, you can. I don't actually want to do it. I just want to differentiate it. Okay. Now there's something else too. The exercise is asking to find the tangent, the equation of the tangent that goes through the point -1 and 1. Well, okay, well, the equation of the tangent is just going to be this, because you see here you have a formula, which is a graph. When you take the derivative of this formula, you actually find the formula, this whole thing here is going to be the formula of the tangent, okay? Because it's the derivative, so it's the formula of the tangent. So if you got a graph like this, it's just an example. This thing here is the formula of this graph, okay? And the derivative is going to be the formula of the tangent, like this, going straight here, or going straight here, or maybe going straight here, something. So going through the point -1 and 1. Okay, now when this is -1, let's just try this out. I'm gonna do something here. So if x equals -1, okay, so it's gonna be 3 plus 1 on top divided by 4 at the bottom, okay? So it's 4 divided by 4, which is 1. So the point -1 and 1 is actually -1 for x is going to be 1 for y in the graph. Okay? Now let's see in here. When x is -1, so let's do this. In here is just going to be 4 times. This is a -1 squared, so it's just 1. Okay? And then you have a minus. And over here, -1, so it's going to be 4 here too. Okay, so it's 4 minus 4, which, well, that's going to be the numerator. Okay, and here you got a -1, so this is 4 squared, 16. So here you're going to have a 4 times 1, 4 minus 4 is 0, divided by 16, which is 0. Look at that. When x is -1, at the derivative, that means that y is going to be 0. Okay? Actually, it's not y that's going to be 0. I'm sorry. The differentiation is going to be 0. The derivative, the tangent, is at 0. What does that mean? That means that it's a horizontal line like this. And I'm going to prove it to you. So we have all this, okay? I'm just going to erase all this stuff. I'm going to show you the graph in here. There you go. I'm going to try to increase this if I can. I don't know. Maybe. Yeah. So you see, let me get something dark, maybe a red. Maybe this one here. Okay, so this is the graph. This is also the graph. This is also the graph of this formula right here, okay? These are the asymptotes. You got a vertical asymptote here, you got another vertical asymptote right here. Okay, so you see, when x equals -1, what do you have in here? A tangent that's a straight line. Why? Because we found out that the differentiation at x -1 equals 0. So there you go. Now, I'm going to maybe show you guys some more exercises. Let's see. Okay, just some plain regular exercises. Here we got x squared plus 3x divided by 6. Differentiate that. Well, differentiating it, I'm just going to do this. I'm not going to use all the notation. I'm just going to try to be quick. It's going to be 2x plus 3 divided by 6. That's the differentiation. Okay. Now another one is 5x to the fourth divided by 8. Differentiate that. So it's going to be 20x cubed over 8. Okay. You can simplify this if you want. So simplifying is going to be dividing everything by 4. We got a 5x cubed over 2. You can do that if you want. Another one is minus 3x minus 2x squared divided by 7x. And it's asking you to differentiate this stuff. Okay. Now, since you got an x here in the numerator and an x in the denominator, you're going to have to use the division rule. Okay. But here's something that you can simplify, right? These minus 3 is multiplying the whole numerator, and the 7 is multiplying the whole denominator. So the minus 3 7ths, you can just repeat them. Okay, what are you left with? You can simplify. You can get this x out of here, you can get this x out of here, and the 2 out of here. You're dividing every term in here by x. Okay, so now all you gotta do is to differentiate. What's the derivative of 3? Well, it's 0. And then you have a minus. Well, this minus 3 7 is multiplying, right? It's gonna be minus and a 2. And here you got 6 7ths. Right? Right. Let's keep going. The next one is easy. 9 over 5x squared. Well, differentiating that, the 9/5 you can just repeat them. Okay, and they're going to multiply the derivative of this. This is x to the minus 2. So it's going to be minus 2 times x to the minus 3. So you can just do this. Okay? Because it's like this, guys. X squared, and here you have a 1. So this is x to the minus 2. And differentiating this, what you have a minus 2x to the minus 2 minus 1, which is, minus 2. Minus 2x to the minus 3, which is minus 2 divided by x cubed. Okay, and that's what we have here. Minus 2 divided by x cubed. Multiplying this stuff, so it's going to be minus 18 over 5x cubed. Okay, let's see if I'm gonna stop this video right here, right now, and do something else. Oh yeah, no, there's something else that I want to show you guys. Remember that the derivative of x to the n, okay, this with respect to x equals n x to the n minus 1. Remember that? Okay. Now let's say that we do have x to the n. We want to do that. But we want n to be negative. So we're just going to say that n, I'm going to put something here like n. Man, these n's are... Okay, n is positive, okay? And let's just say that k equals minus n. So let's try that, okay? Instead of differentiating this, we're going to differentiate derivative of x to the k, but k is negative, so it's going to be derivative of 1 divided by x to the k, okay? And you're differentiating this with respect to x. So what's this going to be? Well, of course, all you got to do here is the same thing, right? X to the minus k. And then you do minus k times x to the minus k minus 1. Yeah, you can do that. But let's not do this. let's do this stuff in here. Look, let's just consider the denominator here one function and the numerator another function. So let's use the division differentiation rule. What do we do? It's g of x, so it's x to the k times the derivative of f of x, which is 0, okay, minus f of x, which is 1, times the derivative of this one, of g of x, which is k. So it's going to be x, actually it's going to be k, okay, to the x k minus 1. All right. And divided by the square of g of x. So it's going to be x to 2k. Now let's do this. Oh, this term disappears because it's multiplying by 0. And then you have a negative k x to the k minus 1. And here you go. You're dividing, okay, by x to the 2k. But here you go. Here you got an x and here you got an x. So the bases are the same. So what do you have to do? All you got to do, because what is this? I'm going to put this x to the minus k over here. Okay, so it's x to the minus 2k. So all I got to do is to add the exponents, right? So k minus 1 minus 2k equals minus k minus 1. This is what I did. K minus 1 minus 2k. Okay, so k minus 2k equals minus k minus 1. That's what I did. So you got here minus k x to the minus k minus 1. Okay, so it's done. I differentiated. But we got to remember that k equals minus n. That means that minus k equals n. So what do we have here? Minus k. We're going to substitute that for n. X minus k, we're going to substitute that for n minus 1. Look at that. Okay. Whenever you differentiate, since k equals x to the minus n, this thing here equals this, okay? Equals derivative of x to the n with respect to x. Why? Because k equals minus n and n equals minus k. So this formula and this formula are the same. Okay? I'm sorry, this thing here and this thing here are equal. So differentiating, doing all this process here, what did I just do? I just did this. I just differentiated. Now differentiating up here shows this formula, okay? And differentiating down here shows the same formula. What does that tell you? It tells you that dx to the n, differentiating right here, dx to the n with respect to x is valid for any n, positive and negative, okay? Oh, but what if the n is 0? Well, then it's going to be the derivative of x to the 0 with respect to x, which means derivative of 1 with respect to x. Since 1 is a constant, it's just going to be 0, okay? And there you go. Let's see here. I think for now it's cool. I'm not going to show anything else for now. See you guys in the next video.